Hello everyone, welcome back to another GIS mathematics lecture video. And in this video I want to go deeper into some actual examples of converting between degrees and radians. In this video I want to do degrees to radians, and in the next video I want to do radians to degrees. So let's look at two examples, and again we're going to keep this idea that 360 degrees equals 2 pi radians, and this sort of x degrees over r radians proportion equals 360 degrees over 2 pi radians proportion. We're going to keep these two facts in mind as we go along. So let's give ourselves a little bit more space. And let's say, what is 150 degrees in radians? 150 degrees in radians. What is that going to look like? Well, first of all, let's think about the quadrant angles so that we can sort of keep ourselves in check here. So we know that 90 degrees is equal to pi over 2 radians, and we know that 180 degrees equals pi radians. And we know that 150 is closer to 180 than 90, so we're going to expect it to be closer to pi, but our answer should certainly not exceed pi. So we kind of have a bounding box to check ourselves. So we are looking for radians, so I always like to put radians on top, and we're just going to do some basic algebra here. So we have x radians is equal to 150 degrees. All right, and this is those proportions that I talked about before. And then again, we know that 2 pi radians is equal to 360 degrees. Okay, hopefully you're with me so far. So now what we're going to do is we're going to reduce this side, because 2 pi radians is the same as saying pi radians is 180 degrees, right? Which we know is true from here. I just did the reduction here. So we have pi over 180 equals x over 150. So now to isolate x, we multiply both sides by 150, and we get x equals 150 pi radians over 180 degrees. So now we can cancel out the zeros, right? We're just going to start reducing this down. So 150 divided by 180 is the same as saying 15 over 18 pi radians, right? And the degrees also cancel out. So 15 over 18, we can divide both of those by 3, and we get 5 over 6 pi radians. Right, we can't divide this any farther, right? 5 is a prime number, so there's no way we could do any more reduction here. So the answer to this equation, right, 150 degrees is equal to 5 over 6 pi radians. Okay, this is our answer. Right, 5 over 6 pi radians. So let's look at another example. Let's look at 75 degrees. Right, 75 degrees in radians. Again, we can do that same sort of thing. We're looking for radians, so x radians over 75 degrees. That's the same as saying 2 pi radians is equal to 360 degrees, right? I'm just using those same proportions. So now we again multiply both sides by 75. So x equals 75 times 2 pi over 360. We can reduce this again, so we can get 75 pi over 180. So we can reduce this down, right? We can divide the top and the bottom by 5. 5 goes into 75 15 times, so this is equal to 15 pi. 5 goes into 180 36 times, right? 36 times 5 is 180. So we have 15 over 36 pi. Again, we can reduce this even further by dividing by 3. So 15 divided by 3 is 5. 36 divided by 3 is 12. And again, 5 is a prime number, so we cannot reduce this anymore. So 5 pi over 12. So let's just think for a second here. If 0 degrees is going to be 0 radians, and 90 degrees is going to be pi radians, or sorry, pi over 2 radians, right? And we know 75 is pretty close to 90. We would expect it to be close to pi over 2, but not quite pi over 2. And just to be clear, pi over 2 in this case would be 6/12. So we are slightly less than pi over 2, which is exactly what we would expect. So this is our answer. So 75 degrees is equal to 5 pi over 12 radians. Hopefully those two examples made sense. If any of this didn't, especially if this sort of algebra right here started to break down for you a little bit, I would encourage you to go back, rewatch the video a couple times until you feel comfortable with the steps that I took. And if you're still struggling, please reach out. Thank you.